Hey everybody, welcome back. Today we're going to continue our discussion on quadratic equations, on not polynomials, on parabolas. Polynomials was the last chapter. And anyway, what we're going to do is we're going to keep looking at these quadratic equations. You'll notice that today our title is graphing f of x, or you can call that the letter y, equals ax squared. That's always been there in the last couple lessons. This is new today, plus bx plus c. So we've had the c before. That was yesterday's topic. We've had the ax squared. That was the very first topic in this chapter, but we've never had this bx before. So as a quick review, quick refresher, yesterday, whenever we looked at this being added on, the c is always the y-intercept, right? Whatever number this is, that's where the graph is going to touch the y-axis, right? And yesterday what we saw is that point was always the vertex. That point was always, like on this example over here, I know that the point 4 right here is going to be on the graph. In fact, I could put that on there right now. I know that that's going to be there. Now, yesterday, that point was always the vertex, right? It would look something like this, or maybe it could go the other way. But that's not going to be the case today. It's still going to be a point, but it may not necessarily be the vertex. In fact, most of the time, it won't be the vertex. It's not going to be like the middle of the graph because of what is in the middle, and that's what we haven't seen yet. Okay, so I'm getting off topic here. Let me go back. So the letter C is going to tell you the y-intercept. The letter A we've seen before. Whatever number this is, this kind of determines how kind of wide or narrow the graph is. If it's opened up really wide, that's when it's a fraction, like 1/2, 1/3, 0.75. Whenever it's a number like 2, 3, 4, it's going to make the graph very, very narrow. So the letter A affects kind of the width or the narrowness of the graph. The letter C affects the up and down part, right? It's going to slide it up and down on the y-axis, on the y-intercept. Today, what we've added is we've added this term in the middle, this x to the first term. And the letter B is going to be the number in front of it, like in this case, the number 8 is the letter B. And so this is going to move the graph to the right or to the left a little bit, and it's not just as obvious as yesterday. Like yesterday, we just looked at this, and we say, oh, the letter C is 4, so we put a dot on 4. It's not going to be so easy today. We're saying, oh, the letter B is 8, so we're going to put a dot somewhere on 8. No. It doesn't work like that because all these numbers kind of influence where it goes left and right. So today, for the first time, these graphs are not going to be centered on the y-axis, right? They're not going to have a vertex on the y-axis. Like here are some of them that we've seen in the past. Kind of look like this. Some of them are, I'm making all these about the same width. I shouldn't do that. Some of them were narrow. Some of them were wider than others. All of them that we've seen so far have always had the axis of symmetry, right? The line that slices halfway through them, right, perfectly down the middle, as the y-axis. Today, it's not going to be like that. Today, they might be moved over here. They might be moved up and over. They might be moved down here somewhere. They might be way over here on the x-axis. The vertex is going to move. They're not going to be perfectly lined up right in the middle along the y-axis like these were. So these examples are not going to apply today. I'm just going to go ahead and erase all of that, and I'll put it back in there really quickly. So that's what the letter B in the bx term there in the middle does to these graphs. So today they're going to get moved to the right and to the left a little bit. Now, how do you do it? It's actually very easy. Could I, if I really wanted to, just make one of those x and y tables and start guessing numbers and plugging them in? You could. That would always work. You know what I mean? You could like do one of these things and just pick numbers, pick 1, 2, 3, plug them in and work it out. But that's not going to be the best way to do it. Because if I just pick 1, 2, and 3, I might just get only half of the graph, right? I might only get this, and then some kids have thought, oh, that means it's a line. No. Like, don't do that. Don't just pick random numbers. There's an actual plan and an actual process that'll make this easier, right? Instead of just guessing random numbers, which I would maybe do that as a last resort in case I forgot everything else that we talk about today, on a test or on a quiz. Instead of just guessing randomly, there is a plan. And it has 2 steps. Let me highlight this really clearly. Here's step 1. Step 1 is to do something they call the find the axis of symmetry, right? That's that line that slices the parabola in half. Find the axis of symmetry. Okay, how do you do that? There's a formula. It looks like this. Negative b over 2 times a. You're like, wait a second, a and b, I don't see any a's and b's in this formula. Oh, well, you actually kind of do. If you remember, look back up here at the top, right? The a is the number that the x squared is being multiplied by. It's the coefficient on the a. So like here's the a. The b is the coefficient on the x to the first power. It's the one that we haven't ever seen before until today. And then the letter c is always, always, always just the plain number at the end. That's also the y-intercept, right? And so even though they're not going to be listed as a, b, and c in the function, in the original problem, you can hopefully get the hang of, okay, whatever the coefficient on the squared term is, that's the a. Whatever is on the x to the first power, whatever it's being multiplied by is the b. And the number that's just a regular number that doesn't have an x on it is always, always, always the letter c. Okay, so now that we have it labeled a, b, and c, I can find the axis of symmetry. It says negative b. Okay, so whatever b is, my b is positive 8. So I'm going to do the opposite of that, right? Negative b, instead of positive 8, I want to have negative 8. And then 2 times a, 2 times my number for a right here. A is 2. And then you can just work this out, right? We all know 2 times 2, that's 4. So this really boils down to negative 8 divided by 4. We all know negative 8 divided by 4. That is negative 2, okay? Negative 2. So my axis of symmetry is negative 2. It's actually x equals negative 2. I should have put that on there. So that means that this graph is going to be centered right here at negative 2, right? Now, you don't have to draw this line. I'm just drawing it just for this very first one. So, like, this is going to be the middle of our graph. Like, half of it's going to be over here. The other half is going to be over here. But I don't know where it's going to go, right? I don't know if it's going to start out way down here or the vertex is going to be here. It's going to be somewhere where the right-hand side is over here and the left-hand side is over here. I just don't know where to put my vertex, that first dot, you know, that gets me going. So, step 1, you find the axis of symmetry. Boom, we did it right here, negative 2. Now, how do you find where you put the dot on this line, right? This is the line of x equals negative 2. Where does our first dot go? Where does our vertex go? So, step 1, we just did it, axis of symmetry. Step 2, substitute that number in for x, back in the original question, right? So if I go back way up here to the original problem, it says 2x squared plus 8x plus 4, right? I'm not doing any math. I just copied that down, right? I just took this and copied it down here. Let me move my board a little bit. And so what you're going to do is take the answer we just got, take this answer, negative 2, and plug it in right here. Every time you see the letter x, we have 2 of them. We're going to put negative 2 in both of those places. All right, so I'm going to do 2 times negative 2 squared, and then plus 8 times negative 2 plus 4. Okay, and some of you can probably do this in your head, right? Negative 2 squared, we have to do the exponents first. I saw a lot of people mess it up, and they did the multiplying first. No, 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 no. You need to do the exponent first. Negative 2 squared. Negative 2 times negative 2 is 4. 4 times 2 is 8. And then I'm just going to put the plus sign there. Then we have 8 times negative 2. 8 times negative 2 is negative 16. And then plus 4. Okay, I can work that out. Let me move my board a little bit higher. 8 plus negative 16, that's negative 8. Negative 8 plus 4 is negative 4, right? And so what you did is you found the vertex. You just found, right here, negative 2, negative 4. That means that our vertex is going to be right here, negative 2, negative 4. The axis of symmetry tells you the x-coordinate. When you plug it in and work it out and get your answer right here, that tells you the y-coordinate of the vertex. And so now, if I go back to my graph, let me kind of get my board adjusted. I know that negative 2, negative 4, negative 2, 1, 2, 3, negative 4 is going to be the vertex of my parabola, right? And so, remember, I still have this point way up here, my y-intercept. Look how far away it is from the vertex. It's way up there. Then if I wanted to get some other points, now if you wanted to go back you could make your x and y table. We already knew, we just did -2, -4. Maybe I do -1 because it's right here next to it. I usually like to do the point that's right next to it, like -1 or -3. So if I put -1, I could put -1 in here for x and work it out. If I put -1 in here, let's see, that would be 1 times 2, -1 times 8, and then plus 4. That'd be -6 plus 4. That's -2. And so -1, -2. I'm going to show you how to do this in another board, so don't panic if that part just kind of confused you. I went too fast. And then since I have this point here that's one place to the right of my axis of symmetry, I can just kind of flip it, do a reflection. One place to the left is going to be the same thing. And then way up here, my y-intercept, that is 2 places to the right of my line of axis of symmetry, I can go 2 places to the left and kind of make my parabola look like this. And so this is really going to be everything we're going to do today. I'm putting it all on one board. Probably a bad idea. But that's the whole process. And I'm going to go back and slow it down a little bit over the next couple boards. But that would be how you do one of these graphs, right? You do the axis of symmetry. Figure that out first. Once you get the axis of symmetry, take that answer, plug it into the problem for x, work it out. That tells you the vertex. Once you get the vertex on there, you can just kind of pick some points that are one spot away from there and fill out the rest of your graph. Okay, let me get a different board because I did everything on one board here and I really didn't intend to go through the whole process. Here's what the questions are going to look like today. I'm going to be honest, I'm going to break this lesson up. I feel bad. I probably went too long on my last couple videos. I'm going to try to make these shorter. Try not to squeeze all that material into one lesson or into one video. So today we're going to get some questions that are not going to ask us to graph it. They're just going to say, hey, find 2 things. Find the axis of symmetry and the vertex. That's all it wants. You don't have to graph it. You don't have to worry about making a coordinate plane. We just want to find the axis of symmetry and then do the vertex for each one of these questions. Okay, step 1, axis of symmetry. Well, before I even do that, let's label them. Right? Here's your letter A, whatever's on the squared term. Whatever's on x to the first degree, that's B. Whatever is degree 0, the plain old number, that's C. So I have my A, B, and C labeled. To find the axis of symmetry, since I underlined it in purple, I'll do axis of symmetry in purple. Here's the formula. Axis of symmetry formula is x equals -b over 2a. And sometimes I forget to put that x, so I'll apologize up front if I forget to put that on there. X equals -b over 2a. So let's plug it in. -b is, okay, here's my b. b is positive 18. So it says -b. That's going to be -18 over 2 times a. 2 times a, okay, my a is 3. So I'm going to do 2 times 3. Obviously, most of you all can do that in your head. 18 divided by, what, that's 6. -18 divided by 6 equals -3. So my axis of symmetry is -3. Okay, easy, simple, very easy substitution question. Okay, now to do the vertex, you take this answer and plug it in for x in both places where the letter x is in the original formula, in the original function. So I'm going to, down here, I'm going to take -3 and substitute it in the spot of the x. Here's the equation. I'm just going to copy it down from over there on the left. Okay, there's my original question, right? I just copied this down right here. Except now I want to put -3, substitute -3 in the spot of the x. So if I put -3 right here, can we do this in our head, right? Can we do -3 squared? -3 times -3 is 9. Are we okay just putting a 9 right there? I hope so. Here it gets a little bit complicated. 18 times -3, I might need a calculator for that. And then plus 10. So 3 times 9, I do know that one in my head, 27. 18 times -3, I think that's -54. You can double check on a calculator if you want. And then plus 10. So 27 plus -54, that's -27. -27 plus 10 equals -17. And so I have my answer. That is only half of my vertex though, right? Remember, to make it the vertex, you take the answer from over here. That goes in the x-coordinate. This, the answer you just got, -17, is the y-coordinate. So my vertex is -3, -17. You can see why I didn't want to graph that one. I would have had to go down 17 places. There we go. All right, let's do a couple more just to make sure that process makes sense. Number 2, I have j of x equals 2x squared minus 4x plus 5. Don't get thrown off with this g, j, f, whatever letter I pick over there, it doesn't matter. It's just, they just like to use a different variety of letters just to kind of keep it interesting. It doesn't really affect the question. So I'm labeled my A, I've labeled my B, I've labeled my C. Step 1, axis of symmetry. My formula is this, x equals negative b over 2a. Okay, let's plug it in. Negative b, my b is right here. Okay, oh, it says negative b, and this is, my b is -4. So it's like -4, right? Because this has a negative, and my equation also has a negative. You know how we can just make that easier? Instead of putting -4, let's just call that +4, right? Whenever you have negative and a negative, remember 2 negatives, make a positive. Whenever you're that type of thing, let's just make it +4. So -4 is the same thing as +4. And then on the bottom, we have 2 times a. 2 times my a is 2. So we have 4 divided by 4, because 2 times 2 is 4. 4 divided by 4 equals 1. So my axis of symmetry is x equals 1. And now to find the vertex, I go back to my original formula. I'm just going to copy it down. This is me copying it down. That is just this problem. I just copied it down right here. And now I'm going to substitute 1 in the spot of the x. So 1 squared, 1 times 1. Okay, that's 1. That's easy. Minus, okay, here, 4 times 1. I guess I should just put 4, but whatever. I put 4 times 1. So here, 2 times 1 is 2, minus 4 times 1, plus 5. Look how simple this is, right? 2 minus 4, that's -2. -2 plus 5 equals 3. Okay, so I got 3. 3 is not my answer, though. It's half of my answer, right? The actual vertex is the first answer, the axis of symmetry, and then the second answer that I just found, 1, 3. Not too bad, right? Okay, let me erase this one because I'm out of room, and I will do the last one in this spot. Number 3, same idea. I can put a 1 right here to make that a little bit more obvious because some kids would get flustered when there's no actual number there. So my A is -1, my B is +6, my C is -3. You might be wondering, hey there, buddy, why are you labeling the letter C? There is no C in the formula. Look at this. There's no letter C in here at all. Well, you might need it eventually. Eventually, we might need that in this class. But on this actual lesson, we actually don't even use the letter C, do we? It's the y-intercept, but whenever we do this, it doesn't really play a part. So negative B, -6, okay? 2 times A, 2 times -1. So my A is negative on this one. 2 times -1. All right, I know that. This is -6 divided by, that's -2. -6 divided by -2 is +3. Sorry, I'm off the bottom of my screen there. This is -2, so -6 divided by -2 is +3. And then I can go back to the original problem. I'm just going to copy it down way up here to give myself some space. So this, I just copied it down up here. And I'm going to take our answer of 3 and I'm going to plug it in up here for the x's. So I'm going to put 3 in the spot of the x's. So here, 3 squared. 3 squared, 3 times 3 is 9. I'm just going to put -1 times 9. Plus 6 times x. The x, remember, is right here. It's 3. 6 times 3. And then -3 at the end. So here, -1 times 9. This is ugly looking, but that's a 6 times 3. 6 times 3 is 18. And then -3. And then I can finish it off. -9 plus 18, that's 9. 9 minus 3 is 6. Now 6 is part of my vertex. It's the last part, right? It's the y-coordinate. The x-coordinate comes from our first answer, 3, 6. All right, there you go. So almost half of the questions today are going to be just like that. It'll say, find the axis of symmetry, boom, right here in purple, then find the vertex. Take your axis of symmetry, plug it in, work it out, boom, you found it, right? So hopefully that's not going to be too difficult for you guys. I have one last board. This is kind of what I showed you at the very beginning. What if they ask you to graph it? If you have to graph it on your own, or you have to pick a graph out of a multiple choice list of a bunch of graphs. How can you tell which graph matches which equation, right? So we'll do the exact same thing, and I'm going to go through this a little bit quicker. I don't know if I have enough room to do all these, but I'll do my best. How do we graph it? Okay, well, I'm going to go back to the process that we have been doing. Step one, I want to do axis of symmetry, right? Here's my A, B, C. So I'm going to do my axis of symmetry. I'm going to do negative b over 2a. I'm going to write it right here so I don't forget. Negative b over 2a. Let me use purple again. So on number 1, negative b. My b is 2, so I'm going to have negative 2 over 2 times a, 2 times 1. That's negative 2 divided by 2. Negative 2 divided by 2 is negative 1. So my axis of symmetry is going to be x equals negative 1. I forgot to put the x equals on it. And now I'm going to take this negative 1, I'm going to plug it in for x in these two places. Let me try to do that right here. So I'm going to take negative 1 and plug it in for x right here. So I'm going to have negative 1 squared. Negative 1 squared is negative 1 times negative 1. That equals 1. Here, 2 times x. My x is the answer I got from up here, negative 1. 2 times negative 1. And then minus 3. And so I've got 1 times 1, that's 1. 2 times negative 1, that's negative 2. Minus 3. And so I have 1 plus negative 2 minus 3. That is negative 1 minus 3. Negative 1 minus 3 is negative 4. And so my vertex is negative 1, negative 4. Right? So I know that negative 1, negative 4, 1, 2, 3, 4, right here is going to be on my graph. It's going to be the vertex. Now, how do I get the rest of it, right? How do I do the rest of my points? Once you get the vertex kind of gives you a good starting point for your x and y table, right? If I want to make one of these x and y tables, I know negative 1 is going to be the middle. I also know this point right here, negative 3, that is the y-intercept. So I can put the y-intercept right here. And then, oh, look what we've got. Man, I think we've got everything we need, right? Here's my vertex. Since this is one spot to the right of my axis of symmetry, I should be able to just go one spot to the left of here, and it'll be the same height. So at negative 2, it should be right there. Right? But if I wanted some other points, you could pick numbers. Maybe I pick 1 or 2 because it's a little bit further to the right. Maybe I pick 1, and then you could also pick a point further to the left. You could pick 1 or 2 if you wanted to, and then you could just plug those in, right? If you put 1 in here, you would have, let's see, x squared. 1 squared would be 1 times 1. Here you would have 2 times 1. Here you would have minus 3. So that would be 3 minus 3. 3 minus 3, make sure my hand is in the way there. 3 minus 3, that's 0. So the point 1, 0, that means that, so here's your axis of symmetry. 2 places to the right was right on the axis. That also means 2 places to the left is going to be on the axis. And you could make your graph from there, right? Here's going to be the first one. You really don't need that many points. I did 5 points. Really, you probably only need 3 points. I didn't even do the number 2, so you probably don't even need that. You could do it just for fun if you wanted to, but you don't need to. Okay, let's do another one. Oh, wait a second. Domain and range. The domain of this one would be all real numbers, right? The domain of all of these is going to be all real numbers. That means it goes forever and ever to the right. It goes forever and ever to the left, because as this gets bigger and bigger, it just keeps getting wider and wider. The range of this one, so the domain, I'm just going to abbreviate all real numbers. The range, this does not go forever and ever on the y-axis, right? It goes up forever and ever, but this graph does not go down. It has a definite bottom, a low point right here, right? The graph does not go below this value, in which this value is 4, negative 4 on the y-axis. So where does this graph kind of live on the y-axis? It lives everywhere greater than or equal to negative 4, right? Negative 4 on the y-axis, and above is where this graph is located. This graph is never going to be below negative 4 on the y-axis. Okay. All right, that is the domain and range. That's how you graph one of these. Let me do another one. I'll do this one in red just to make it stand out. Whoa. Okay, I know one of the points of this graph already. I can see this right here, -5. So I know that 1, 2, 3, 1, 2, 3, 4, 5. I know that -5 is going to be one of the points. I just don't know everything else, right? The fact that this is negative tells me it's going to open down. So this is going to be the opposite of my blue in here. This is going to be opening down because when the A is negative, here's my A, here's my B, here's my C. When the A is negative, you know it opens down. All right, let's do the axis of symmetry. Axis of symmetry says -b over 2a. So I'm going to have -8 over 2 times a. 2 times my a right here is -2. 2 times -2 is -4. So I have -8 divided by -4, that's 2. So I know my, or over here, this kind of line right here, x equals 2. Whoa, if I can draw it straight, that's going to be the middle. That's going to be the middle of my parabola. All right, now how do I find the vertex? I take the answer we just got and we plug it in. We just got an answer of 2. We take it and we plug it in for x right there and right there. So let's actually, I'm going to write the equation again because I'm getting sloppy. This is just me copying the question down. And now I'm going to take our answer and plug it in to the problem. Our answer was 2. So 2 squared, that's 4. So we have -2 times 4. Right here you have 8 times 2. Can I just put 16? I hope so. And then -5. Let's see, -2 times 4, that's -8. -8 plus 16 minus 5. -8 plus 16, that's 8. 8 minus 5 is 3. So that tells me if I make my little, man, I'm way out of, if I make my little, I guess I'll just kind of put it down here because I'm out of space. That tells me that the point 2, 3 is the 2, 3 is on my graph as well. So I'm going to go to the point 2, 3. 2, 1, 2, 3, right here. Okay? Now, I already know -5 is one of the points, right? 0, -5, because that is right there in the original question. I can kind of just use reflections and get the other point, right? You see how this dot is 2 places, right? 1, 2. It's 2 places to the right or to the left of our axis of symmetry. I can go 2 places to the right of that and make a matching point right there at the point 4, -5. And honestly, that's really all you need to do. If you wanted just for your own benefit to pick another number, like maybe you pick this number right here, 3, since we haven't done 3 yet. Maybe you pick 3. You could go back to this problem. You could put 3 in the place of x, and you could work it out again if you really, really wanted to. Whoa, give yourself another point. Holy cow, everything's falling over here. Let me just use the real eraser instead of trying to use my fingers. If you wanted a third point, you could do that. Like you could put 3 in there and say -2 times 3, since I picked 3. 3 squared is 9. And then you could do 8 times 3, and then you could have the -5 at the end. And so then you would have -18 plus 24 minus 5. -18 plus 24 is 6. 6 minus 5 is 1. And so you could have 3, 1, 3, 1. And then since that, see how this value is 1 spot to the right? You could go 1 spot to the left of your axis of symmetry and get this point as well. And now look, I have 5 points to make this look really good. All right. Now, if I was going to present this for my final answer, I would erase that axis of symmetry, that dotted line. You really don't need that when you get to your final answer. So there you have it. That's how you graph that one. If I did want to do the domain and range, the domain is all real numbers because this thing goes forever and ever to the left and it goes forever and ever to the right. The domain on all of these so far in this chapter is going to be all real numbers. The range is going to be where this graph is on the y-axis. Now this goes down forever and ever and ever, but it doesn't go up. It never gets higher than this point right here, right? This is the value 1, 2, 3. 3 on the y-axis. This graph is below that. It is less than or equal to 3, positive 3. This graph does not get any higher than 3, than this line right here that I'm erasing with my finger. Okay. You know what? I had one more on here. I think I'm just going to forget about that because I'm already at 30 minutes. So I didn't intend for this video to be that long. I apologize. But that is the basics. We would do number 3 the exact same way. If you want to try it on your own, you could. But this graph would probably be pretty big. Well, you know what? If you want to stop the video now, you can. If you do want me to do it, I guess I should. Here's the axis of symmetry. A, B, C. I would do negative B. Negative 20 is going to be positive 20. And then 2 times A, 2 times 5 is 10. So this would have an axis of symmetry at 2, just like this other one did. And then I would have to put 2 in the place of X and work it out. And let me switch to a different color because that green doesn't show up very well. If I took this question, I'm going to put it way up here. If I put 2 in the place of X, 2 squared is 4, so I would have 5 times 4. Here, 20 times 2 is 40. And here, 15 at the end. So that would be 20 minus 40 plus 15. 20 minus 40 is negative 20. Negative 20 plus 15 is negative 5. So we would have a vertex of 2, negative 5 right here. When I plugged in 2, I got an answer of negative 5. So this one would have a point 2, negative 5, way down here. And then you could pick other points as well to plug in there. This one would probably go off my graph because you see how this is 5? It's going to be really narrow. Like the y-intercept is 15. I don't even have 15 on my graph. It would be way up here. This thing would go super, super high, super, super fast. It would be something like this. I mean, it's very narrow compared to the others. That would have a domain of all real numbers. It would have a range of y greater than or equal to negative 5 because it's at negative 5 and above. So anyway, I'm going to put some questions on the Big Ideas Math site. Hopefully they are okay for you guys. Tomorrow we'll still be on this lesson. This is 8.3 in our book. Tomorrow we'll talk about minimum and maximums, which is very, very, very similar to what we just did today. So thanks so much for watching, and I'll catch you guys tomorrow.